Thanks for the opportunity to be here. I think my first trip to China was in 1987, and Shenzhen was quite a different town at that time. It's amazing to see it grow over those 30, 40 years. Archana mentioned the various projects that we have that are managed by volunteer leaders, people that are from the community that have expressed interest in collaborating with other companies on a common goal of producing a common spec, working towards a new product, working on a new technology. I'm going to go through some of these in a little more detail in the next 40 minutes. And our following speaker, Rajiv, is going to cover some of the software projects that are on here. So, Archana mentioned that we have about 9 different projects. We have a networking project, which includes some sub-projects. We have a rack and power group that focuses on the rack and the power ingredients, and then that group also has some sub-projects that they launched. We have a storage and server project. We have a data center facilities group that's really looking at how the data center operates and providing guidelines for co-location providers to assist them in making their co-lo facility the most efficient facility available and ready for this higher efficiency IT equipment. We have an HPC work group, telco work group, hardware management, open system firmware, and security. I'm going to go through these in a little more detail in a few minutes. We also launched in the last year or two a series of embedded software projects, and these are just some of those. And again, I'm going to defer to Rajiv, who will come up next and talk about these in a little more detail. Back on the hardware side, we do have a group where we've consolidated all of the rack mechanicals and power delivery into one work group. They support the open rack standard, which is it's a standard that fits onto the same 600 millimeter by 1200 millimeter tile layout, but the IT space where the equipment installs into the rack is 21 inches wide or 538 millimeters wide. So you have a little more frontal area. You're taking advantage of the space and more efficient use of that space. We also have another standard that was introduced by Olympus that is being installed by Microsoft around the globe. It supports their Azure software stack. And that product also is part of the OCP portfolio. That product actually fits into a standard EIA rack, also known as the EIA 310 rack, the rack that the industry has used for the last umpteen years. Along with the rack mechanical specifications and collaboration, we also look at the power rectifiers. One of the features of power efficiency is the ability to share power. So we have 12-volt and 48-volt power rectifiers that provide centralized power into the rack and then feed that power to the IT equipment through a couple of bus bars on the back. Those rectifiers offer a variety of power resiliency options and AC and DC input options. In total, those rectifiers can support virtually any facility around the globe, offering both AC and DC input, as well as the option to install battery backup units into those slots. And so in some cases, you can actually eliminate your facilities level UPS with a UPS functionality built directly into the rack with these rectifier, substituting the rectifier for the BBU. I mentioned that we have a rack and power, a couple of rack and power subgroups. There's actually 2 of those. The first is a group that was launched this last year. We call it the Advanced Cooling Solutions. If you look across the industry, we are faced with huge challenges in cooling our racks today. We see power densities that are reaching 50 and 100 kilowatts If you look at some of the new GPU appliances, I'll use the NVIDIA example. They recently released a 4U appliance that puts out 10,000 watts from 4Us. If you stuff that full of, and fill up your rack to the full 40U capacity, you're going to need about 100 kilowatts of power, but also 100 kilowatts of cooling capacity. Some of that capacity or that cooling can't be achieved through standard airflow, and so we're looking at alternatives to provide cooling in the most efficient manner. One of those alternatives is cold plate, where you traditionally bring in a warm water or cool water stream and attach heat exchangers to the top of the memory and the processor, and provide a heat exchange and pump that water out to a separate cooling system built in the facility. Another type of advanced cooling is the use of immersion, where you put tanks into your facilities and you actually install the equipment into a non-conductive liquid bath that again transfers the heat into that liquid where it's then transferred outside of the facility. The third type of cooling opportunity is with rear door heat exchangers, and this is basically using your same types of racks, but you're bolting a heat exchanger onto the back that brings in cool water and allows you to cool that air as it exits the rack and before it's dispersed into the data center. The reason for any of these projects is really to harmonize the requirements that the data center IT group has, harmonize the requirements that we place on the facilities, which ideally will allow our supplier base to build products designed for common requirements, ideally allow many different suppliers to build these products cost effectively and to use their design resources most efficiently, and allow our consumers, those companies that operate clouds, to consume from a variety of suppliers that have agreed to work together on the harmonization of these requirements. We also have another project called the PowerShelf Interoperability Project, and much like advanced cooling, we are trying to harmonize the requirements of the power rectifier that goes into that shelf with the intent of creating interoperability of the rectifier and any BBU modules to plug into it. Another big project is our server project. This project is really looking at a variety of server types. Steve showed you two of those, the openEDGE sleds from Inspur and WeWin. There's a variety of other suppliers that make sleds similar to that comply and interoperate with OpenRack. We have a variety of GPU appliances, common designs and specifications that have been contributed and products available on the marketplace. We support a variety of compute sleds or rackable servers that fit into the standard EIA 310 rack as well. We also have two different subgroups that have been formed out of this group. Several years ago, we had a dozen companies that got together and defined a new mezzanine standard. That mezzanine standard actually evolved to the 2.0 standard. That's this little green L-shaped board here in the bottom right. You'll see samples of that out in the expo hall outside. Mellanox and many other companies have adopted that standard and built various controllers that plug into the servers. A variety of server manufacturers now support that interface. More recently, we had, again, that same group of 12 companies get together and define a new mezzanine standard called the NIC or Network Interface Card. It's the third generation standard, so the NIC 3.0 mezzanine card. A few changes were made to increase and adopt PCI Gen 3, add more sideband signals, and allow for easier installation from outside the system. Another one of our core projects is our networking group. It's a very active group. They work on not only hardware switchgear, but have a variety of software sub-projects that we'll talk about. We really span from your kind of traditional 10, 25 gigahertz switchgear up to 400 gig switchgear. So these are companies that have come in and actually provide and contribute a spec for these products and open up all their design files. Because they've done this, it allows other companies to quickly evolve their product and create new derivative products.
然后再去创造一些衍生的这种项目。比如说，我们可以改变这种在后门式的电源，或者做出一些其他的改变。毕竟我们这个组合是非常大的，我们有很大的这种设计组合，所以这种这个交换器它的发展是非常快的。我们不光做过这种交换器。
Defining new optical transceivers that are
同样呢，也做过这种光学的无线收发器。
are able to be manufactured at lower cost.
而且现在我们的这个生产成本更低。
That group also looks at telemetry and campus-based
变得更有针对性。
We have a group specialized or focused in the telecom segment. The idea is we leverage the products that are being developed in some of these other groups. Leverage them to the point where they could be used specifically in the telecom market, deployed into central offices, regional offices, and in some cases, edge locations around the globe. So what they've done is they've taken the OpenRack sled and they've hardened it so that it meets some of the EMI requirements that the carriers have insisted on having. They also have done that with some of the server products. Recently, that group has been working together on developing a standardized hardware platform for edge computing. And we expect to see more and more work come out of that collaboration. With that, the idea is to have a common platform for edge computing with a lot of different suppliers that can build different functions that go into that. Functions that address some of the low latency requirements and some of the new applications that are being driven out at the edge. We also have a variety of GPON and optical line termination devices that are available that follow some of these common specifications. This group is comprised of carriers from around the globe. A large contributor helped out with a lot of these specs has been AT&T. And Deutsche Telecom,
而且有很多的大的组织，比如说 AT&T 等等。
Other carriers around the globe.
还有其他的。
Give you an idea on openEDGE. Here's just a math on how the applications have evolved over time. I'll just point out a couple of those. If you think back on home automation, we had temperature sensors and the ability to turn on and off lights within our homes for many years now. As we get more sophisticated in that control, rather than simply turn on and off appliances, we actually want to affect the power grid and use that information to affect how power is actually being delivered to a city or to the home. When we do that, the response times end up being very, very quick.
然后我们把我们的发现应用到新的项目之中，最后还能提高我们的速度。反应时间可以提高几秒到10秒之间。而且也可以保证我们在整个电网上运输自己的能源。我们就希望我们所有的项目能够更进一步的向边缘靠拢。
So the net of that is that we had a lot more horsepower that's needed at the edge.
而且在边缘上，我们需要更多的能源。所以在这个部分呢，我们就希望能够在边缘化实行高性能的计算。
So edge products could sit in a factory somewhere. It could sit at the base of a cell tower.
我们可以在各种各样的地方，比如说工厂里，在电塔，或者说在很多比较偏远的地区都可以实行。就比如说在生产汽车方面，我们可 可以一方面在云端提供信息，比如说这个车的速度、车的配置，但是与此同时呢，我们还要去做自动化，去控制这个汽车，在这个路上控制这些汽车，比如说还要告诉我们，在车有故障的时候，我们应该如何发送信息，所以。在不同的地方，我们有不同的需求。比如说在偏远地区，在高速公路上，所以在硬件方面也有各种各样的改变，所以我们的这个运营方呢也有不同的要求和不同的选择，在选用这个开放计算的产品的时候。
We also have a storage project,
同样，我们也有存储式的这个项目。刚才 Steve 也给我们展示了一些，这其中呢有一些这种存盘。同样呢，我们还和各种各样的云服务公司在合作。那如果你可以想一想，在过去我们有一个标准化的硬盘，但现在在过去的一段时间里呢，它也在不停的演进。所以我们希望能够让它有更大的用处，提高它的效用。所以我们希望能够给它创造一个更好的环境。所以我们创造了一些接口，那这些接口呢，都可以得到这些硬盘的支持。这也是在效率方面一个非常大的改变，而且也改变了我们的存储。这就是因为我们改变了接收信息的方式。另外还有这个归档存储，可以组合各种各样的要求。还有这个状态监管，还有hardware的说明和参数。这边我们讲一下这个硬件管理。那在这个底下，你可以看到各种各样的这个硬件，比如说服务器、网络、存储、动力能源，还有这个边缘。我们就会发现每一个这个设施呢，它所要支持的这个不同的管理是不一样的。所以我们希望能够有这种机架管理系统来统一管理这些不同的需求。所以我们的确有这种开放式的RMC。最终呢，这个目的呢，就是希望能够创造这种开源式的机架管理体系。另外，我们还有一个开放式的开放系统固件。比如说，我们有不同的公司来进行供应，来进行协作。进行开源，所以在这个过程之中呢，我们所做的就是要去看这个英特尔所提供的解决方案，使用的芯片使用的 UEFI 它是怎么运作的。这边还有一个例子叫做 Core Boot。它就是已经有这个驱动在里面了。同样它也可以和这个 UEFI 进行合作。这样就可以让我们应用到各种各样的平台上，但是所采用的这个代码是相通的。那去年我们也出了一个项目，是跟安全有关系的。因为现在这个安全问题呢，它也是我们的一个威胁。我们从硬件还有设计、解决方案方面各个方面进行考量。首先呢，就是硬件可信度量跟。
that
就是我们
it's
在开启这个
is
系统的
booting
时
up
候，
and using firmware that came from a trusted
我们
source.
就要使
In the
用
event that
可
it's
信
not a trusted
源
source
所
or
提供的
we
这个固
detect an
件。
anomaly during the boot process, we want
如果
to
在这个过程
quarantine
中
that
有
hardware
我
and
们
take it
不
offline.
认识或者不
We
信
also
任
are
的
looking at the chain
这
of
个
custody of that
固
hardware,
件呢，我们要
make
进行
sure
识别。
that we don't expose that hardware to
另外一
handling
种呢
that could introduce a new threat
就是
to
我
the
们要
hardware.
避免这
There's
个
various
固
ways
件
that
或
you
者说
can do
硬
that
件
through
暴露
secure
在
and
其他
measured
未知的
boot
风险之中。
processes. We have to look at the recovery process
另
to
外，还
make
要
sure that when
去
we
考虑这种
detect
还
a
原的过
suspect
程。
firmware, that we are able to actually recover and install good firmware. We can use
我们要还
attenuation
原
to do
并且
that
安装就是
and
可
secure
信的固
execution
件，还
to
有
do
这种
that.
可
So
信执行。
architecturally, that's
所以
the
从架构
approach
方
that
面
this
来
group
说
is
呢，
looking at. It's co-managed by technical
这个
leaders
系统
from Microsoft
是由
and
微
from
软、
Google.
谷
Both of
歌
those companies have
这些
root
公
of
司
trust
它的这个
hardware
工
that
程
they
师来共
introduced
同维
last
护
year.
的。
Google has the Titan chip, and
谷歌提供芯
Microsoft
片，
has the
微
Cerebras
软
chip. So
它
we're
有它自
looking
己的
at
芯
how we
片，
can use
所
those
以我们就可
hardware
以看一
devices
下我们应该如何
and
使
a
用这些
common
硬
API
件设
across
备
both companies
来进行更好的管理，
to create a secure root of
来
trust
创造一种
for the
更好
hardware.
的可信度量跟
So that's a
来保
wrap
守
up on
的
the
硬件。
projects.
这
Thank
就
you
是
very
我们
much.
我的基本介绍，非常感谢大家。